Hey there YouTube, still no name, still on conic sections. We just got done with parabolas, so now we're on to probably the most famous of all conic sections, the circle. Now to the math desk, where hopefully there's a circle of some sort.
If you remember from last time, you get a circle by chopping off a slice of a cone parallel to a base. The definition of a circle is a shape where every point along it is the same distance, or radius, from the center at every point. That's why a compass is so good at drawing perfect circles. It keeps one point stuck at the center, and the other leg stays the same distance away as you turn it.
See? Perfect circle. As long as you don't zoom in to actually be able to see it.
Anyway, how do we describe this shape algebraically with numbers and letters and stuff? Well, let's start by drawing a circle centered at the origin 0, 0, and let's give it a radius of, let's say, 2. Now, draw a line from the center out to any point. Now, since we're working with an x and y axis here, that means that this point will be a coordinate of x, y. Also, this is a circle, so the distance from the center to the edge will always be the same no matter where you draw this to. That is, a length of 2. So now we know these three pieces of information. How do we relate them to each other? What if we drew a right triangle with the radius as hypotenuse? Then this would be one leg, and this would be another. We even know what length these legs are. Since this circle is centered at the origin, the distance this way is just the x value, and the distance this way is just the y value. Right triangles follow the Pythagorean theorem a squared plus b squared equals c squared. So that means x squared plus y squared equals 2 squared, or 4. This is true for any point along this circle, since even the negative numbers, when they are squared, become positive. So, for any circle centered at the origin, x squared plus y squared equals the radius squared.
I'm going to give you a sec to write that one down because it's going to show up all over in trigonometry, from radians to trigonometric identities to polar graphing to even vectors. This parody of Pythagoras' work shows up so often because it links triangles to circles and to many other things as well. This allows us to use our knowledge of triangles to answer all sorts of different questions about the world. Thus, our understanding of trigonons, which is Greek for triangles, and metrons, measurements, gives us triangle measurement, or trigonometry. I think I'm just going to let that set in. You can write down if you want, x squared plus y squared equals r squared. So, how about them sports?
While the other me was lounging around showing off his ignorance of athletics, a two-dimensional earthquake rattled our circle and shifted it up and to the right. Now its center is at 1, 2. How are we supposed to model it now? Well, you can still draw lines out from the center along the radius and make triangles out of them, but the length of the legs is no longer x and y. This one would be x minus 1, because the center starts at 1, not 0. And this leg would be y minus 2, since that's where the center is. So the equation would become x minus 1 squared plus y minus 2 squared equals 4. This leads us to our standard form for circles with a radius of r and a center at h, k. X minus h squared plus y minus k squared equals r squared.
Great, so what's going to be on the test? Your face. No, your face will not be on the test. Oh. Well, that won't happen as long as you study and you don't stay up all night playing Assassin's Creed before the test. And that's what I'm here to help you with. The first one, not the second one.
Something that usually comes up on an exam is taking something fully expanded like this, asking you to identify which conic section it is, having you rewrite it in its standard or graphing form, and then identifying what its defining characteristics are. We did this with parabolas last time. If there's only an x squared or a y squared but not both, it's a parabola. Then we completed the square with whatever variable had the squared term, and used it to find the vertex, focus, and directrix. If there are both x squareds and y squareds, then you need to look at the coefficients next to these squareds. If they are the same, it is a circle. And yes, negative signs matter here. 4 and negative 4 do not count as the same in this case. Both have coefficients of 1 in this case, so it's definitely a circle. Now we start the process of completing the square. If you're shaky on what that is, watch my last video to get straightened out.
Wahahaha! My plan to make everyone watch all my videos is working.
So, since we have x squareds and y squareds, we're going to have to complete both squares. First, we group together the x's and the y's, and subtract the constant over to the right, since that's where the constant goes in the standard form of a circle. Then complete the square with both x and y. Half of negative 4 is negative 2, so it goes there, and that becomes x minus 2 squared minus the extra, which is 4. Half of 10 is 5, so this becomes y plus 5 squared with 25 extra. Now, you can either subtract the extra on the left, or just directly add it over to the right and save a step. Either way, you end up with x minus 2 squared plus y plus 5 squared equals 16. This circle would be centered at 2, negative 5, with a radius of 4, which is the square root of 16. Alright, one more. Does this have x squared and y squared? Yep. Same coefficients for both? It's a circle for sure. So let's put it into standard form. Group the x's together, get the y's together, and the 1's just going to have to be a loner over there. Factor out the 2 from both of those, so there's only one x squared and only one y squared in the parentheses. Complete the square now. Half of negative 1 is 1/2, so this becomes x minus 1/2 squared. The extra would normally be 1/4, because that's 1/2 squared, but it's being multiplied by 2, so the extra is actually going to be 1/2. Now over to the y. Half of 1 is positive 1/2, so it would be y plus 1/2 squared. Again, the extra should be 1/2 squared, but it's being multiplied by 2, so it's going to be 1/2. Add the extra to the other side, and you get 2 times x minus 1/2 squared plus 2 times y plus 1/2 squared equals 2. Are we done? Well, there definitely weren't any coefficients in the standard form, though. Luckily, this is a circle, so these coefficients are the same, and we can divide the whole equation by that number. In the end, we end up with x minus 1/2 squared plus y plus 1/2 squared equals 1. What does that tell us? The center circle is at 1/2, negative 1/2, and the radius is the square root of 1, or 1. Quick note about sketching the graph. What I tend to do when drawing circles is draw a point where the center is, and then move out however far the radius is in 4 directions. It looks like I drew crosshairs on my whiteboard. Anyway, connect the dots in a roughly circular shape and you'll be good to go, no matter how sloppy it ends up actually being. Remember, if it's not perfect, just keep zooming out until it is.
Is it perfect yet?
Sweet! Should be good to go on circles. Now, if you have any other problems, you can go review through this thing or look in the links below again. One more question before you go, though. Remember that one step where we had to divide by 2 on that last problem? Yeah, that one. What if they weren't the same number? It obviously wouldn't be a circle anymore. But what shape would it be? And what would you do next? Well, you're either going to have to look it up on your own, or wait till the next video. The evil plan is working yet again. Thanks for watching, and take care.